Okay, so all about pi. Now, if you notice this progression using shapes with greater size each time, I'm getting closer and closer to what you would call a perfect circle. Well, there's really no perfect circle because if you think about it, since pi goes on forever, and the biggest pi numbers have millions and millions of digits, and it goes on with no pattern and it's irrational forever and ever, you know, there's no such thing as a perfect circle. So, as you get closer to a circle, the more sides it is, you're going to get closer to the best relationship between the length of its sides and the length of the diameter, the radius, the circumference, and everything. Okay, so consider a circle up here. The radius is the distance from the center to any point. If I cut up this circle into plates, obviously the smaller I can cut them, the more accurate I can be. You're getting closer and closer to a perfect circle. But with this example, you can clearly see, if I cut just 16 of these plates and put them in a row like this, you can see that it's roughly the same as a parallelogram with that height and the base. So the area of that would be base times height. Now, if you look at the numbers, you can see that the height is roughly the same thing as the radius of a circle. Okay? So, this height equals radius. So if you look at the formula for the circumference of a circle, 2 times pi times r. This parallelogram has a base and a height. Calling that base and height. The base is the length of these triangles rowed up from here to here, which is half of the circumference. So since the circumference is 2 times pi times the radius, half of that will just be pi times the radius. So this is pi times radius, which is the base, and then the height is radius. So pi times radius and times radius gives you pi times radius squared. So that's how you get the formula for the circumference of the circle to the area of the circle. Okay, cut.